Hello mathematicians, puzzlers, and other curious people. In this video, we are going to talk about checkerboard and domino problems. Now, if that sounds like kids' games, that's great because it's seriously the checkerboard, from checkers, and and dominoes, like for matching things up with, but we're going to use them a little differently in this case. If you can get an actual checkerboard and some dominoes to try this out with, that would be great. If not, you can just use some graph paper, and that's what I'll be doing to be able to capture it conveniently in the computer. So here I've got two 8x8 checkerboards marked out, and we'll copy these if we need some more. So the key question in checkerboard and domino problems is, can we cover this checkerboard with dominoes? So a domino takes up two spots together like this, of course. Say maybe this is the 3 and the 4. I don't know, whatever. It doesn't even matter which one it is. We know it takes two spaces. Well, immediately we can see one way to tile the checkerboard with dominoes. The basic grid. It's not very creative. It's not that interesting, but we can do it. But it turns out there are also more interesting ways. Like this way right here, it looks more interesting than the other because it's not just straight up in a grid. So there we go. So there we have some direction changes as the dominoes are going around. And you can do all kinds of things with this. So a question that immediately comes to mind for some people as they're doing this is, what would happen if we changed some things about the board? So what would happen if, for example, we tried to eliminate some spaces? So if we try to leave that space out, can we come up with a tiling? So take a minute, try some things, and see what happens. Uh-oh. I notice I have a leftover space there. So you might wonder, is that a result of the way I chose to try to tile things out? Because, I was working in a particular systematic way. So take a minute, form your own opinion about whether that result will always happen. So it turns out, although you can end up with different squares being the other one out, you will always end up with one extra left out square if you skip this one, because each domino covers two squares of the checkerboard. So since we have an 8x8 checkerboard, it's got 64 spaces on it. If each domino is covering two spaces, we have to have exactly 32 dominoes. But if we try to cover only 63 of the spaces, well, we have a problem, because we'd have 31.5 dominoes. When the 0.5 dominoes, that's not a thing. So that's why we end up with an extra spot uncovered. So then the question that comes to people's minds is, well, can that extra uncovered spot be just anywhere? Or are there specific places it can and cannot be? Like we saw here, it was a neighboring corner. And it's not difficult to imagine that if we went the other way around, applied like a similar strategy, kind of symmetrically, but in the other way around, we could get this far corner here instead. What about this corner? So what if we try to come up with a tiling for the other spaces here so that that corner is left out? So we're trying to cover 62 spaces. So theoretically, that would be 31 dominoes worth of space being covered. We haven't seen any reason yet why that couldn't happen. So let's try it. And here we have a problem, because I can either do that and let those be the 2 empty spaces. Uh-oh. Or I can say, okay, well, that's a domino, but then that leaves those 2 as empty spaces. They're not together. I can't put a domino on them. Or I can do that, and the same thing happens. Maybe it was a result of the way I tiled around. Maybe it wasn't. Try out some different things and form an opinion about whether it is or is not possible to tile all but the 2 diagonally opposite corners of a checkerboard, and see if you can come up with a reason why that would be or would not be possible. So either a tiling or a reason it can't happen. So one thing people try as they're trying to form an opinion is they might try a smaller checkerboard, like a 2x2. Now with a 2x2, you can clearly see it's impossible because a 2x2 is just not flexible enough. We've got then only 2 remaining spaces to try to put a domino on, and we can't put a domino diagonally in this type of problem. So try some things out. Maybe try a 4x4 or a 6x6 checkerboard and see if you can find any reasons from that might transfer up. And again, if you can try a real checkerboard instead of just a diagram of it, sometimes that helps because you get your hands physically on the dominoes and can move them around and try different things. That leaves you with something to work on. So for now, I am going to let you get to that and say, calc you later.